What song are you listening to right now?
Started from the Bottom by Drake.
Started from the bottom, now we're here. Started from the bottom.
Excuse me. What song are you listening to right now?
Moonglow by Billie Holiday.
It must have been Moonglow.
Excuse me, what song are you listening to today?
Tornado of Souls by Megadeth.
What are you listening to right now? Yo, what song are you listening to?
What are you doing in my house?
No,
right
what
now?
song are you listening to, Phil?
Hello everyone. For our MLVA project, Will and I have decided to make a song suggestion algorithm. After a lot of brainstorming, we really wanted to use our love for music and appreciation for how it really does bring so many people together into a project, and decided to make a song suggestion algorithm in which you input a song, and based off several different clustering algorithms, we're going to output 5 of the top songs suggested by that algorithm. So we're going to get right into it and kind of how we executed this project.
I can start by talking a little bit about our data set. Our data set was found on Kaggle and contains a bunch of songs, 28,372 to be exact, and many different features ranging from the artist name, the song name, the genre, to more unique metadata such as loudness, acousticness, danceability, instrumentalness, etc. We explored the data briefly and visualized some trends. We thought it would be interesting to see how the data changed, or how the songs changed by decade. So we plotted some of the features by decade, and it was interesting to see how something like danceability changed over time. From 1960 to 2020, the songs clearly became more danceable, and for something like acousticness, the songs clearly over the decades that we observed became less acoustic. After exploring the data, we moved towards building a pipeline to prepare it for our models. We found that the most relevant categorical variables to keep would be genre and topic. And so we dropped some of the categories such as song name or artist name, because we didn't believe that would be as relevant. So we built our pipeline scaling the numeric data and one hot encoding the categorical data, and ultimately normalized the entire process data set as well.
After creating our pipeline, we ran several different clustering algorithms. The ones we ran were k-means, GMM, Birch, dbScan, and hdbScan. And then to actually create our song suggestions, we would cluster our songs using one of the algorithms. And then we had another algorithm that ran, first it found what cluster the song was in, and then it used a cosine distance formula to find the 5 closest songs to that song within their cluster. After doing this, we really wanted to visualize our data better, and we used TSNE values, which is a way to visualize multidimensional clustering into 2 dimensions, and we think it looked really good. So we're going to go over some of our results now. The first algorithm we ran was k-means, as it was the one we were most familiar with from class. The first thing we did was try to discover the elbow point, and then we used that to find that it was around 10 clusters, and used those 10 clusters to run k-means, and this was our result. The next algorithm we ran was GMM, or Gaussian mixture model. This model uses a more probabilistic approach using Gaussian distributions to cluster the data, and these are the results we found using the GMM model. After GMM, we ran Birch, which is a clustering algorithm that uses hierarchical tree clustering, and this one is found to be really good on large data sets, and we think we yielded really good results from the Birch algorithm. Next, we ran dbScan, which clusters based on density points and also is able to identify outliers or noise outliers points, which do not really fit in the clusters that they identify. Lastly, we ran hdbScan, which was a bit better with larger data sets, as it uses a hierarchical structure, but it's just pretty much very similar to dbScan, and I was able to find a lot of different outliers as well. And these were our results for that.
Overall, I had a great experience working with Sam on this project. I think we both learned a ton. From working with the data set, determining relevant features, to fine-tuning our model to get results that we were both happy with. I think it was very challenging but rewarding. And then even visualization, there was a lot using the T-SNE method to reduce the dimensionality of our data set. It was cool to see the results that gave us. I think we got some great graphs to display our clustering algorithms. And lastly, it was great to see some of the overlap in the results of our clustering algorithms, which kind of proved to us that our recommendation system was functioning and working properly.
Building off what Will said, I think it was really cool that the data set we used spanned from 1950 to present, and also so many different genres, from jazz, hip hop, pop, rock, all those different genres, just because I think it touches even more people, and the fact that music is such a great way to connect with friends, family, people around the world. It's just kind of a universal language, so it was really cool to see that part of things. To wrap up the video, those songs that we kind of heard at the beginning, we're gonna kind of show what our algorithm produced, and the song suggestions it produced based off those songs. So let you guys see a little bit of a real life example of how our algorithm ran and how it performed.
I got a pocket full of sunshine. I got a love and I know that it's.
I'm doing 60 in a 35. I'm in the Rari, I'm just trying to drive. Cops pull me over, say, sir, are you drunk or high?
It must have been moon glow. We're up in the blue.
Someone learn money to cover up or spread it.